All right, here is my i8080 emulator on my Raspberry Pi. I have the instructions listed out over here. This is the same exact instruction file that we'll be running on here. Just have it over here for ease of reference as we go through here. All right, so we're gonna go ahead and restart the kernel, run all cells. All right, and up pops the emulator. So the first set of instructions were loading and moving register bytes and incrementing and decrementing registers A and B. And then at the end of this section, we'll move the byte that I think is stored in B, and we'll move those across all other bytes. All right, so load the instructions and then run next instruction. It's going to do nothing. Then increment B, decrement B, increment B, increment A, decrement A, and then we're going to move a new value into B, and then we're going to move that value across all registers. All right, now next we're going to push and pop B and C, and we're going to take the complement of A. So run next instruction. First, it's going to put a new value in A and a new value, or it's going to move A to B. Then it's going to push B and C to the SP, and then it's going to pop them, and it switches them when it pops them back. And then we're going to take the complement of A. Okay. And then the next one here, it loads some new values in so that each register has a different value. And then it's just going to shift them all left. Just another example of moving across registers and testing that. So we're going to run the next instruction. All right, now we have different value in each register, and we are going to start shifting those over to the left. And the last you'll see E will populate with A. Now, the next one we're going to do here is add and subtract instructions, and then testing the carry flag along with those. So first one we have is adding B to A, and then subtracting B to A. Should just put it back at what it was. Then we're going to set the carry flag, so you'll see that at the bottom. Carry flag to true. And then we're going to add B to A with carry. And it sets the carry flag back to false. But just so we can get back to our original value, I did a carry complement, which sets the carry back to true, and then subtract with carry, and it gets us back to original value on A. All right, now the next one is we're going to move byte B over to A, and we're just going to try some new move functions. So we're going to do that through D, and then we're going to compare those two using the compare B instruction. And what should happen is that the zero flag should go to true because they are equal. So let's try that. So we're moving B to D, and then D is going to go to A, and so now B and A are the same. We're going to compare those, and we can see the 0 flag went true. All right, then the next we're gonna do here is we're gonna take the complement of A, and then we're gonna do a bitwise and that'll show everything going to zeros. Then we're gonna do the bitwise OR, which ends up with just giving us a copy of B. And then we're gonna compare that with the immediate byte, and that we're going to compare the immediate byte with A, which will turn the 0 flag back to false. So let's check that out. Run next instruction. So complement of A, and then we're going to do the bitwise AND. So it was comparing that to B, and none of the values were included in both, so they all went to 0. Now we're going to do bitwise OR, and it'll just pop up with your bits that were in 0 or in B. And then we're going to compare the immediate, which is 0F, which is 4 ones in binary. And of course that's not equal to what's in A, so your 0 will go back to false. Next is going to be loading 16 bits into the stack, and then increment and decrement that. So we can see that pops up in the stack, increment, decrement. Okay. And then we're gonna add and subtract immediate bytes to A. And at the end here, we're gonna have a jump if carry flag is set. The carry flag's not gonna be set, so this jump is not gonna do anything. And then I also threw instruction in there that doesn't do anything, or that isn't part of the instruction list, just to see what happens. Okay, so we're adding 5 to A, and we're subtracting 1 from A. Then add with carry to A, but there is no carry, so it's just going to add 3. And then subtract with carry, but there is no carry, so it's going to subtract 2. And then we're going to do a logical OR with 1, 1, 1. So that just fills you in there. Because either 0F, which is 1, 1, 1, or 1, 0, 1, 1, which was what A was, fills in those bits, because each of them had a 1 in each bit spot. All right, and then next is going to be nothing going to happen because it's a jump if carry, and carry flag is false. And then the next one's going to be an invalid instruction, so nothing's going to happen. And then our next one, we're going to decrement A until it's 0. And you can see jump if not 0 is the instruction there. So it's just going to keep jumping back to this decrement A instruction until it hits 0. So let's watch that happen here. So we're decrementing A, and then we're back. And we just keep jumping back to that number 63 instruction. I'll go a little faster here. All right, we're almost there. Now it's finally 0, so now we're going to break through that 63rd instruction. All right. So now we're going to simply just push and pop D. and this is DE. So it's gonna push DE to the stack, and then it's gonna pop them back, and it switches them when it does that. All right, now we're gonna do a bit swap of immediate value, and then a bitwise AND operation on the immediate value. And the immediate value in both of these cases is 0F, again, 1, 1, 1, 1. All right, and that's gonna all, we're first gonna move E to A. So that A has values. Then we're gonna do a bit swap of 1, 1, 1, 1. And then we're going to do the logical AND, which should fill it back up. Oh no, it's AND, not OR. So it's AND, so it's only taken the spots that are ones in both. So that's why it did that. And then on these next ones, I'm not quite sure what I did wrong here. Is the pushing onto A off the stack and then popping back onto the stack. So this might be working correctly, it might not, I'm not sure. But here's the next 3 instructions. So you can see that something pushes onto the stack, and then something pops onto the, or then I move C to A, and then something pops off of it and AC turns true when I do that. And I'm not quite sure what's going on there or if I have that working right. And then the last instruction is to jump back to the beginning. So it jumps back to PC 0, but still maintains all the values that were in the registers and the stack when we left off, and the flags. And that's it. It's a quick demonstration of my emulator. Thanks.